Hey everyone, Ronak this side. I hope you all are doing well. So let's say the problem of the day. So the problem here we are same as tomorrow, but here maximum total sub-array of value 2. So basically we have to calculate the maximum total value between the sub-arrays. So basically what we are given a nums array. Let's consider 1, 2, 3, 5. Okay, we are given an integer k. For example, it's 3. We have to, I mean, we have to create the k amount of subarray from this nums. I mean, from here we have to create three subarrays from this. And how we can create subarrays? Subarrays may overlap, but exact same subarray cannot be chosen. Okay, we can't choose same subarray. Tomorrow, what we are doing? We are choosing the whole array as a subarray thrice, and we are returning the value. And the value of subarray is defined by, suppose we choose a subarray 1, 2, 3. So what will the value of subarray? Value of subarray is maximum of this subarray minus minimum of this subarray. Okay, so what's it gonna be? It's gonna be max of this, which is 3. So value of this subarray gonna be 3 minus 1. That is true. It's maximum minus minimum of that subarray. Okay, so first of all, let's see how we are going to approach it. So uh, first thing to notice is, if, for example, how we are going to choose subarray. Suppose we are going to use a pointer called. So how we are going to choose? We are going to choose the, I mean, subarray by removing this pointer left and right. Okay. I mean, this is 1, 2, 3 is a subarray. 2, 4 is 2, 3, 4 is a subarray. 3, 4, 5 is a subarray. 5, 5 is a subarray. Here 2, 2 is a subarray. 3, 4 is a subarray, 1 to 5 is also a subarray. So what we are going to do is we are going to shift the left and right pointer to create new subarrays. Okay, and how we are going to shift? For example, if I mean, first of all, we are going to fix this left and going to shift it 1, 2, 3, 4, 5. Okay, and then going to move it and then 1, 2, 3, 4. Okay, like nested loops. So what we are going to do is, I mean, shifting like this. So for example, we have, so how we are going to generate is first fix the left. So here left equal to 0. So the subarray is 1, 2, 3, 4, 5. Here right equal to, what is right equal to 0, 1, 2, 3, 4, right equal to 4. Okay. And shift right, I mean decrease the right. So it's gonna become 1, 2, 3, 4. It's gonna become 1, 2, 3, 1, 2, 1. Okay. At left, now shift the left, move left equal to 1. So it gonna become 2, 3, 4, 5, and then keep decreasing the left and keep decreasing the right. Okay, this is right, this is left. Keep decreasing the right until it crosses the left. Okay, so 2, 3, 4, 2, 3, 2, like that. And now for like that we can generate like L equal to 2. We have 3, 4, 5, 3, 4, 3. At L equal to 3 we have 4, 5 and 4. At L equal to 4 we got 5. Okay, so here are the total number of sub-arrays, and total number of sub-arrays here is n to n plus 1 by 2. That is, I mean, sum of n natural numbers, and that's gonna become 15. So here we got 15, 5, 4, 9, 10, 11, 12, 13, 14, and 15. Okay, so we got 15 sub-arrays here. So, and now another thing to notice is, uh, if we decrease the size of subarray, the value of subarray is gonna decrease. Okay, for example, we decrease the size of subarray, or the maximum gonna increase or decrease. Okay, for example, here the maximum is 5. If we decrease the size, I mean 1, 4, 3, 2, what, here maximum is 5, here maximum is 4. So anyhow, if you decrease the size, the maximum are not going to, I mean, not going to increase. It gonna either remain same or it gonna either decrease. Okay, so maximum gonna either remain same or either gonna decrease if we decrease the size of. And what about minimum? I mean, for example, here minimum is 1, 2, 3, 4, 5. Minimum is 1, and here minimum is 2. Okay, we decrease the size of array, so we are not going to get another minimum. either going to get the same as minimum, or we are going to get max, I mean more than minimum. Okay, so minimum gonna increase on decreasing the size of subarray. So the total overall value equal to max minus min. Okay, so if max is decreasing, I mean, and min is increasing, so what will total value? I mean, positive is decreasing and negative is increasing. I mean, it's leaning toward negative, so the total value gonna decrease. So on decreasing this, if we decrease the size of subarray, the value of that subarray gonna decrease. Okay, so in this chunk, I mean, let's call it a chunk. I mean, at l equal to 0, at chunk l equal to 0, if which should have, I mean, which one should have maximum value? Okay, the which one should have maximum value, the which has the maximum size. Okay, so here the maximum value is max minus, I mean, the value of this is 5 minus 1 4. Here value is 4 minus 1 3. Here value is 3 minus 1 2. Here value is 2 minus 1 1. Here value is 1 minus 1, because maximum is 1. And okay, so as we decrease the size, the, I mean, as we decrease the size, the value gonna decrease. You can try on whatever array you might think this is in sorted order or whatever, it's gonna decrease. So, and similarly here, 5 minus 2 is 5 minus 2 is, I mean, 3 2 1 0, I mean, like that. So if we decrease the size of all this, it's gonna decrease. So what, how we are going to proceed here is, I mean, let's example we are going to use here is max if. Okay, and how we are going to use it max if? By using priority queue. So we are going to use priority queue of int if. It gonna store three integers, and it's the first integer gonna store the value of subarray. This is gonna store the left index of subarray. This is gonna store the right index of subarray. Okay, so I mean, if we see this here, here and here too. So, okay, so this is our priority queue. So if you see this, for example, here we got five chunk 1, chunk 2, chunk 3, chunk 4, chunk 5. Okay, so for example, we have five chunks here: 1, 2, 3, 4, 5. Okay, five chunks, and all are in sorted order. Okay, so here is top is the maximum, and here is minimum. Okay. In each chunk each is sorted order. Okay, I mean these chunks represent the value. So value here is 4321. I mean 43210. Okay, here is 321 3210 here 8. I mean whatever the value, all are in sorted order. Okay, so if we are at this chunk, we don't know what is the maximum value of this. Okay, if we are at this chunk, we don't know maximum value of these four. Okay, so what we are going to do, we are going to pick the first of, I mean, first of all of them, and gonna store it in priority queue. Okay, so how it gonna look? For consider it's here. Okay, for example, let's consider it's 4 here too. Okay, it can be, and it's 3 here, and it's 3 here too. Okay, one. I mean, for example, we got the value of subarray like this. Okay, so in first chunk, what we are going to do, we are going to, I mean, top of all. Okay, here l equal to 0, here l equal to 1, l equal to 2, l equal to 3, l equal to 4. Okay, so these are value at l equal to 0, r equal to 0, l equal to 0, r equal to 1, l equal to 0, r equal to 2, l equal to 0, r equal to 3, l equal to 0, r equal to 4. Okay, similarly, this is l1 and r L1 and R4. Okay, the last element L1 and R4. This is, I mean, L1 and R3. This is L1 and R2. This is L1 and R1. Okay, so that's one of 0. Like, look here, it's L1 R4. It's L1 R3. L1 R2. And I mean, 432 is L0. Okay, L0 R1, and this is L0 R0. Okay, so like that. So it's all gonna be like that. So what we are in first priority queue, we are going to store these, I mean the top element of all of this. Okay, so priority queue gonna look like 4 and L0 R4. I mean it's 0 and 4, it's, I mean, representing L and R just to have better understanding. 3 L1 and R is here 4. Okay, here R is R equal to 4, here R equal to 3, R equal to 2, R equal to 1. Okay, so cannot exceed this by, so 3 L1 and R4, 3 L2 R4, and what we are going to cut is 3 L2 R4, and then again here 1 L3 R4 and 1 L4 R4. So it's how our priority queue gonna look like. Okay, so what we are going to do now is we are going to pop out, we are in answer, for example we are given k equal to 5. Okay, I mean for example k equal to 5. So what we are going to do is while k minus minus, and we have to make sure that priority queue doesn't become empty. So while k minus minus, what we are going to do is we need 5 subarrays. Okay, so the first subarray gonna become 0 to 4, and that is 4. So what we are going to do, answer plus equal to value. So I mean, and auto type that contains value L and R. Okay, so it's pq dot top, and now we are going, it's get the top element of priority queue that has maximum. I mean it says maxip. So it's going always going to stored in maximum order, and we are going to top. Okay, after storing that value we are going to remove it. Okay, and after removing, what we are going to do is, after removing we are going to insert the same, I mean insert the, we are going to insert on priority queue of same chunk. Okay, the maximum of same chunk. And what will the maximum of same chunk, and if chunk was same, left one remain same, and right one decrease by 1. Okay, so we are going to pq dot its pop, we are going to insert, I mean in place, maximum of L and R minus 1 minus minimum of L R minus 1 comma L comma R minus 1. Okay, so we are going to insert the second, I mean we are going to insert the second greatest element of that same chunk we are moving. Okay, so for example here we moved, I mean 4 from 0 and 4. What will be the next element of that chunk from 0? L0 and R3. So it's gonna become L0 and R3. Okay, so it's gonna 4 L0 R3. We are going to insert 4 L0 R3. It's gonna become a top at priority queue. And after inserting, what we are going to do, we are going to simply close the while loop, and we inserted. So now answer become, what was the value first? Answer become 4. So answer become 4. 0 plus 4, answer equal to 0 plus 4 plus, and now we are going to top. So top was this, so again it's 4, so we are going to plus 4 at answer, and it's from 0 chunk. Okay, so L equal to 0 and R equal to 3. So L equal to 0, R equal to 3. So what we are going to, maximum of I mean maximum at range 3 comma 0. I mean suppose this is a function which returns maximum at that range. Okay, I mean we are going to define that function later, maximum and minimum. So it's return on that range. Okay, so after inserting that, we are going to again call that on same range. Okay, I mean same chunk, we are going to insert another top element of that same chunk. Okay, so left gonna remain same, and we are going to decrease right by 1. Okay, so now left is 0 and right is 3, so it's become 0 comma decrease 3 by 1 to 0 comma 2, maximum of 0 comma 2 minus minimum of 0 comma 2. So 0 comma 2 is maximum minus minimum, the value of 0 comma 2 is 0 comma 2, l equal to 0, 2, it's is 2. Okay, so we are going to insert 2 l0 r2, l0 r2 here. Okay, so after inserting, now again move to top and now remove the top element. So here we are removing the 3 l1 r4. So after removing the 3 l1 and k equal to 5, so k equal to 1 2 3 4 5, we did it 1 2, we are currently at third iteration. So k equal to 5, we are going to remove the top 3 and going to do plus 3, and after removing, what we are going to do, insert the another value of that same chunk by reducing r by 1. So we are going to l1, I mean same chunk, l1, l equal to 1 and r equal to 3. Okay, 4 minus 1 3, so l1 r3, l1 r3 gonna become 3, so 3 l1 r3. Okay, so 3 l1 r3. So after inserting 3 l1 r3, again we move to another and now get the max. So maximum here is again 3 l1 r3, and after getting l1 and r3, what we are going to insert is 3 l1 plus 3 per 2 plus 3. We are going to insert the same chunk, I mean l1 comma, we are going to insert of same chunk, that is l1 comma r3, I mean r3 minus 1, that is r2, l1 r2. And what is l1 r2? l1 r2 is 1, so 1 l1 r2. You can store it here too, I'm just storing it here because we don't have enough space there. So l1 r2, and after inserting this, we again move to last iteration, and where we pop out the top element, and top element is l2 r4. So l2 r4, we are popping out the l2 r4 and its value is 3, so add 3 l2 r4, and after deleting l2 r4, we have to insert l2 and r3, decrease 4 by 3. Okay, so l2 r3, which is l2 r3 is 1, so 1 l2 r3. Okay, I'm inserting here to lack of space, due to lack of space. So what we are total answer we got? We got answer equal to 4, 4, 8, 9, 10, 11, 12, 13, 14, 15. We got 15. And what range we used? We used first 0 to 4, then we used 0 to 3, then we used 1 to 4, then we used 2 to 4, and 1 to 4, and 1 to 3, and 2 to 4. 1 to 3 and 2 to 4. Okay, so these are the range we used. Okay, so let's code this, and about this max and mean I'm going to show that later. Okay, so for example, let's initialize the priority key of int int, let's call it pq, and first we have to insert the topmost elements of every chunk. Okay, so we are going to, for int I equal to 0, I less than dot size I plus plus, and we are going to get, I mean, first suppose we got the, I mean, equal to, we have to get the, what I'm writing, you gonna understand it soon. So what, taking r as constant, and r is nums dot size pq dot in place answer dot maxi minus answer dot mini. I mean, suppose answer is a pair, answer is a data type, node data type that contains two value maxi and mini on passing query of that range. Okay, and basically answer returns the maximum and I mean this line returns the maximum and minimum value of on that range I to nums dot. Okay, on that range 0 to I mean nums dot size minus 1. And after doing this, what we are going to, we are also have to pass the range. So that is I comma nums dot size minus 1. I mean I have int n equal to nums dot size. Okay, so that's gonna help us. So we are going to push the all elements on. I mean we are going to push everything on that queue top of every element, top of every chunk by querying from I to n minus 1. Well, from here we are changing the left and taking the right equal to constant, that is right equal to 4 here. And what we are after that, what we are going to do is while k minus minus and right q isn't empty, what we are going to do is until what we are doing here is first get the value auto value comma left index comma right index equal to pq dot top, and after that what we are going to do is and answer plus equal to value and initialize, let me take answer equal to 0 of int answer plus equal to value, and after getting that value we are going to push the another I mean push the another subarray of that same chunk. Okay, we have to push the another subarray of that same chunk. So what we are going to do is node next array equal to query left comma right minus 1. We are taking the same chunk, so left gonna become same and right gonna decrease by 1. Okay, so next where we have to post it into pq dot emplace pq dot emplace next where dot max minus max where dot min. Okay, in mini maxi mini, and also we have to pass the index, that is l comma r minus 1, and after this simply we have to close the while loop. Okay, so that's all, return answer. Okay, and you must wonder what is this code. I mean, so let me create here extract of node that has maxi and mini. Okay, and we have to pass the constructor max equal to minus 1, min equal to int max. Okay, and after that, so basically node contains I mean maximum or minimum, and this query gonna return maximum and minimum on that range of. And now how we are going to get this query function. So basically what we are going to use here is segment tree. Okay, so let's move to another part of this question, which is segment tree. I mean I should have explained this in first, but I thought let me take you through the logic and explain that segment, introduce that segment tree later. Okay, so segment tree. So basically, what segment tree is? For example, we have an array 3, 2, 1, 6, and 5. So what segment tree is? Done segment tree. I mean, you should know segment tree so that work on range. Okay, so suppose we are given at 3. I mean, first range is 0 to 0. Second range is 0 to 1. Third range is, I mean, second range is 1 to 1. Third range is 2 to 2. 3 to 3, and 4 to 4. And yeah, this represents the max. Okay, for example, we have to calculate the max. So what is the maximum at this range 0 to 0? It's 3, and here it's 2, it's 1, it's 6, and it's 5. And after combining these two, it's gonna become 0 and 1. So what is maximum at 0 and 1? This is maximum in between these two nodes, which is 3. And after combining these two, it's gonna become maximum of these two is 6 in range 2 comma 3. Okay, and maximum of this is 5. So, and maximum of this is 2 to, maximum is 6 on 2 to 4. The range is 2 to 4. In range is 0, 1, 2 to 4. The maximum is 6. Okay, and in range this 0 to 4, the maximum gonna become 6 here too. Okay, so this is maxip which runs on the. Okay, so I think you have to know the segment tree first. Of that the prerequisite of it. So after knowing the segment tree, we are going to, instead of storing max, we are going to store node here, and which is gonna contain max and min. So max here is 3 and min is 2. I mean, in this node, and in this node max is 1, min is also 1. Here max is 6, min is also 6, max is 5, min is also 5, it's also 3, max is 2, and here from 1 and 6, max is 6 and min is 1. Here max is 6 and min is 1 in those two. And between max 3 and 6, the maximum is 6, and between 2 and 1, minimum is 1. Okay, so it the segmentary on basis of nodes which gonna give us the, I mean, maximum and minimum. So how we gonna, so let me show you the code of our segmentary. Okay, so here's the code of segmentary. So this is xmn. So we have to do this mx and mn here too. This is maximum, this is minimum. And minimum. Okay, so here say the code of segmentary. Okay, so basically here we are building a segmentary where what we are doing is we are setting segment of that index. The maximum is maximum of the sub segmentaries. Here the current maximum is the maximum against the maximum of another two nodes, and here the minimum is minimum of minimum among the minimum of that two nodes. Okay, two child nodes. And here the query is returning a node that contain maximum and minimum of left and right node. Okay, so after, so this query gonna return the node, and node gonna contain maximum and minimum. Okay, so if we submit the code, so basically we have to write tuple. I mean, we have to pass the tuple here. So priority queue gonna arrange it on basis of most the first value. Okay, I mean node is capital here. Node here. Now let's see what the hell is. Okay, the query is taking index low and high. So I mean, it basically means the first index that also gonna always gonna become 0. I mean, if you know the segment tree, you have, if, first of all you have to know the segment tree, and that's the part of segment tree that's beyond the scope of this video. So if you want a separate video, I can make on this. So let's pass this 0 and low and high. So low always gonna become 0 and high always gonna become and -1. Similarly here we have to pass 0 comma 0 comma and -1. Okay, like that. So now I can submit the code. Okay, so first of all, I forgot this code. This is to build the segment tree, and current we are getting conflict with the answer variable. So I replace the variable with current, which are getting the top of the everything, and that will make it to top. The current is getting the top of every, I mean every chunk, and returning it. I think we forgot to pop pq.pop, and we have to run it while it's not empty, till it's not empty. Okay, and answer data type is long too. Okay, now it's runs perfectly. So let's submit the code and save. Okay, we got a better code now. So first of all, I think you get this part of the code, and about remaining this part, you first have to know the segment tree, how segment tree works, and the modification we did here in segment tree. We are getting, instead of storing integer, we are storing nodes, and each nodes containing maximum and minimum. So basically, in one segment tree, we are getting the both maximum and minimum. Okay, so that's a little modification here in the segment tree, and this basically builds the segment tree. This decide this size of segment tree, and this this query function returns the node which contains maximum and minimum in this range. Okay, last two digits are the range. Last two, arguments are the range. Here, L and R minus one, we are subtracting from right, decreasing from right, because we have to keep the chunks same. So we are reducing here. So basically, it's the whole code we got. Okay, so I hope you like this video. So that's it for today. So please make sure to subscribe to Tensor. Till then, keep smiling, keep coding.